Yes. Last time this question has been given to you. Show that the series summation n the power minus z converges absolutely and uniformly in any bounded closed domain in which real part of z is greater than 1. So I'm solving this exercise. So let's choose our un to be equal to, let unz is equal to n the power minus z. Now it is given that your real part of z is greater than 1. That means if z is equal to x plus iota y, that means this real part, that is x is greater than 1. So from this, x is greater than 1. So let us choose our x to be equal to 1 plus some delta, where delta is a positive number. So let's check the mod, that is then mod of unz is equal to mod of n the power minus z, that is mod of n raised to the power, this is x plus iota y, which is equal to mod of n the power minus x into n the power minus iota y. We know that mod for n the power iota y is 1. So this is equal to mod of n the power minus x. पीछे हमने रिमार्क पढ़ा था कि इसका मॉड जो है मॉड ऑफ n raised to the power iota y is 1. You can also think it as 1 over n the power x and the power iota y. Now since mod of n the power iota y is equal to 1, so we are left with 1 over n the power x. Your x is a positive, so this mod is also positive, which is equal to 1 over n raised to the power, this is 1 plus delta. Now we choose this 1 over n raised to the power minus delta to be equal to mn. So let mn is equal to 1 over n raised to the power 1 plus delta. Since this 1 plus delta is greater than 1, so this is convergent. Since 1 plus delta is greater than 1, as delta is positive, so the series summation mn is convergent by p-test. So this is convergent. Now since summation unz mod is equal to summation mn and summation mn is convergent, so by Weierstrass M test, the given series is convergent uniformly. So this converges uniformly. For which this real part of z is greater than 1. Alright, so next question. Here is a note, that is, if z is a complex number, then sin z and cos z need not be bounded. We know that for real numbers, mod of sin z is lying between -1 and 1. Cos z is also lying between -n and 1. So this function is bounded if z belongs to the real numbers. But if z belongs to the complex number, then these functions need not be bounded. So let's check. Discuss the uniform convergence of the series summation cos nz over n cube. So let हमें इसकी यूनिफॉर्म कन्वर्जेंस पढ़नी है and it is not given that whether z belongs to real number or complex number. We will discuss both the cases. So let u and z is equal to this summation n going from 1 to infinity cos of nz over n cube. So case 1, if z is real. So in that case, if we check mod of u and z, that is mod of cos nz over n cube. Now this cos nz, this is less than equal to, this mod is because it is bounded in case of real numbers. So mod of cos nz is less than equal to 1. 1 over n cube, because cos of theta is less than equal to 1 for all theta belongs to the real numbers. But this is convergent. This is convergent because 3 is greater than 1. So by Weierstrass M test, if you choose this as to be your Mn, this mod of u and z is less than equal to this Mn, and Mn is convergent. So by Weierstrass M test, summation u and z mod converges uniformly if z is real. So this is the case for the real. Next, for the complex number, let's check. If z is not a real number, the second case, if z is not a real number, so then if we check the limit n tends to infinity u and z, this is equal to, let's check the limit. I'm taking the limit to check whether the given series is a convergent or not. If it is not convergent, that if the limit not comes out to be 0, then the series is not convergent. If the limit comes out to be 0, then the series is convergent. So this limit cos of nz, over n cube, this is equal to limit n tends to infinity. Now what is cos of nz? We know that this is in the exponential form. It is e the power iota nz plus e the power minus iota nz over 2 with n cube. Okay, if you put the value for n to be equal to infinity, so this is a infinity over infinity form. That means this limit is not equal to 0. And whenever the limit of, we know that the result, that is if limit n tends to infinity of the an sequence, if this comes out to be 0, then series is convergent. Otherwise, if limit does not comes out to be 0, then the series is not convergent. ये आपके सबसे फर्स्ट पेज में जो हमने पावर सीरीज में रिमार्क किया था वहाँ पर ये रिजल्ट आपका प्रेजेंट है. So the series does not converge. So the series summation u and z and going from 1 to infinity does not converge uniformly if z is not real number. Hence the series converges uniformly only for all the points on real axis. So hence the given series converges only for the real numbers uniformly only for all the points on the real axis. Okay, not for the complex numbers. So next, show that the series summation 1 over z square minus n square pi square converges uniformly for all values of z except z equal to plus minus n pi. अगर z इक्वल टू प्लस माइनस एन पाई हो गया तो ये तो बिल्कुल ही डिफाइन नहीं होगा ना. तो ये पॉइंट छोड़कर बाकी सभी पॉइंट्स पे ये यूनिफॉर्मली कन्वर्ज कर रही है. So let's show. Again, I'm letting summation u and z and going from 1 to infinity is equal to summation and going to 1 to infinity. What is u and z here? It is 1 over z square minus n square pi square. Okay, let's check the mod for u and z. Okay, mod of u and z, then this is equal to mod of 1 over z square minus n square pi square. Can I interchange the terms in the denominator? Yes. This is strictly less than equal to n square pi square minus z square. I have interchanged the terms. This is for wait, it is not less than equal to, वो मैं next step पे करूँगी. This is equal to, because mod of a minus b is equal to mod of b minus a. So I have interchanged the terms in the denominator. Now this 1 over mod a minus b is less than equal to 1 over mod a minus mod b. So mod of a minus mod of b. Is this clear? Alright. So with this I have to write for n square pi square to be greater than mod of z square, so that this denominator should be positive. For the sake of the denominator, so I have written n square pi square greater than mod of z square, that is your n is greater than mod z over, आप पाई नीचे ले जाओ, pi. So this is a condition for your n. Alright, this is clear. Next, which is further equal to 1 over n square pi square minus, now what is mod of z? This is r, so this is r square. We know that absolute value of, that is the mod of z, modulus of z is r. Z is equal to e the power r e the power iota theta in polar coordinates. So mod of z is equal to r mod of e the power iota theta. So this is r, this is modulus of e the power iota theta. So if you use the Euler's formula, this is cos of theta plus iota sine of theta, and mod for this is 1 because cos square theta plus sin square theta root is 1. That's why I always take mod z is equal to r. That is the modulus of z is r. So n square pi square minus r square. Now take this as your mn. So let mn is equal to 1 over n square pi square minus r square. Oh, this is so good. If pi square and r square is not present, 1 over n square is there, then my series is convergent. So let's take the another series, that is, let Cn to be equal to 1 over n square. Now this is convergent. Alright. Now if we look at by the comparison test, the behavior for Mn is what? So let's check the limit n tends to infinity, that is your Mn over Cn. This is equal to limit n tends to infinity. This is n square pi square minus r square. This is n square. So if you take your n square outside, you will be getting 1 over pi square minus r square over n square. Okay, now if you put the limit and infinity over here, this term is 0, so you are left with 1 over pi square. Now this limit is not equal to 0 or infinity. Hence, Mn has the same behavior as that for Cn. Both the series have the same behavior. So, by comparison test, summation Mn and summation Cn, where n is going from 1 to infinity, they will have the same behavior. So Mn is convergent. Now since our mod of u and z, this is less than equal to summation of Mn and summation Mn is convergent. So by Weierstrass M test, the given series converges uniformly. For all values of z except z is equal to plus minus n pi. So there is an exercise for you. Show that the series summation z to the power n over z to the power 2n plus 1 converges uniformly on the set mod z less than equal to r, further less than 1. So a hint is given to you. When you check your mod of u and z, this will be mod of zn over z to the power 2n plus 1. You interchange the terms for the denominator, and then this 1 over mod of a plus b is less than equal to 1 over mod a minus mod b. You use the identity, and then that is further less than equal to, because mod z is less than equal to r, so this is less than equal to r to the power n over 1 minus r to the power 2n. And then start with, you take this as your mn and prove the series to be uniformly convergent. Alright, next. There is a very good result. Now this summation a and zn is your power series. Now if this power series converges for all real values of z, then the series also converges for all complex values of z. अगर ये series real values के लिए converge कर रही है, then ये series complex values के लिए भी converge करेगी. ठीक है? So let's prove this result. Let's start. We take any complex number first. Let z naught be any complex number. Alright. Now I'm taking R to be any positive real number. So let R be any positive real number such that आपका ये जो R है वो उस कॉम्प्लेक्स नंबर के मॉड से बड़ा है. Okay. So then if R is greater than mod of Z naught, then can I write summation n going to 1 to infinity an instead of Z I write R n. This is convergent. Why? Because it is given that the series converges for all real values. Now R is a positive real number, so the summation an R the power n is convergent as R is a real. Okay. तो हम R के लिए भी इसको कन्वर्जेंट लिख सकते हैं. अगर ये समीशन कन्वर्जेंट है दैट मीन्स इसकी लिमिट n टेंड्स टू इन्फिनिटी 0 है, जो हमने स्टार्टिंग में रिजल्ट पढ़ा है. सो द लिमिट n टू इन्फिनिटी an r the power n is this is 0. अगर ये लिमिट 0 ना होती तो सीरीज कन्वर्जेंट नहीं होती. अब हम यहाँ पर डेफिनेशन ले रहे हैं जो हमने पहले पढ़ी थी कि जब भी सीरीज़ कन्वर्जेंट है तो उनका जो मॉड है दैट इज़ लेस देन एप्सिलॉन फॉर एन. हमारी यूनिफॉर्मली कन्वर्जेंट वाली डेफिनेशन जहाँ पर हमारा जो पॉजिटिव रियल नंबर n था, जो पॉजिटिव इंटीजर n था, वो सभी के सभी z के लिए काम कर रहा था, जो खाली एप्सिलॉन पे डिपेंड करता है बट पॉइंट पे डिपेंड नहीं करता. क्योंकि ये सीरीज़ सभी रियल वैल्यूज़ के लिए कन्वर्ज कर रही है दैट मीन्स ये सीरीज़ जो है यूनिफॉर्मली कन्वर्जेंट होगी. बिकॉज अगर ये पॉइंट वाइज होती तो एक एक नंबर पे डिपेंड करता है n. ठीक है, एप्सिलॉन पे भी डिपेंड करता और उस पॉइंट पर भी डिपेंड करता. बट हम कह रहे हैं कि सभी रियल वैल्यूज़ के लिए कन्वर्ज कर रही है दैट मीन्स वो जो n होगा वो सभी पॉइंट्स के लिए काम कर रहा है. तो मैं यहाँ पर यूनिफॉर्मली कन्वर्जेंट की डेफिनेशन यूज़ करूँगी. सो दस वहाँ पर हम एप्सिलॉन पॉजिटिव लेते थे, तो सपोज़ मैंने एप्सिलॉन पॉजिटिव लिया है, सपोज़ मैं इस एप्सिलॉन को 1 ले लेती हूँ. ठीक है, इट इज़ ग्रेटर देन 0, सो लेट्स टेक दिस एप्सिलॉन टू बी 1. यू कैन चूज एनी एप्सिलॉन दैट शुड बी ग्रेटर देन 0. सो फॉर एप्सिलॉन इक्वल टू 1 देयर एग्जिस्ट अ पॉजिटिव इंटीजर n that depends upon epsilon depending on epsilon such that mod for an r the power n, this mod should be less than epsilon. That means this mod should be less than 1 for n greater than equal to n. You can check your uniformly convergent definition. Next, this implies mod of an is mod of an to mod of Rn. This is less than 1 for n greater than equal to n. So this implies this mod of an is strictly less than 1 over r the power n for n greater than equal to n. Okay. Now let's take the mod. Here r is positive because it is a positive real number. Summation mod of an z naught the power n. देखो ये मैंने जो लिया है दिस इज़ फॉर n ग्रेटर देन इक्वल टू n. तो n की वैल्यू अब मैं क्योंकि ग्रेटर देन इक्वल टू n के लिए ये रिजल्ट वैलिड है तो मैं यहाँ पर अब सीरीज़ कैपिटल n से स्टार्ट कर रही हूँ जहाँ तक मेरी ये चीज़ वैलिड है और फिर इन्फिनिटी पे जाऊंगी, ठीक है। और यहाँ पर अब मैंने कॉम्प्लेक्स नंबर के लिए मैं ये मॉड चेक कर रही हूँ, अभी तक रियल नंबर्स के लिए मैंने देखा है, अब मैं कॉम्प्लेक्स नंबर के लिए यहाँ पर लिख रही हूँ, दैट इज़ z नॉट द पावर n विच इज़ इक्वल टू summation n going from n to infinity mod of an mod of z naught the power n. Now this mod of an is strictly less than 1 over r the power n, तो इसलिए इस mod of an को मैंने यहाँ पर अब यूज़ करना है, दिस इज स्ट्रिक्टली लेस देन समीशन, तभी मैं यहाँ पर n जो है कैपिटल n से स्टार्ट कर रही हूँ, मैंने ये चीज़ यहाँ पर यूज़ किया, और ये चीज़ किस लिए लेस देन 1 द पावर आर एन है, फॉर n ग्रेटर देन इक्वल टू n, इसलिए n को आपको n से स्टार्ट करना है. So instead of mod of n I am writing 1 over r the power n into mod of z naught the power n. Okay, so this is equal to summation z naught over r whole power n, n starts from n to infinity. Okay, अब z नॉट ओवर r आपकी क्या है, जीपी सीरीज है y, बिकॉज z नॉट इज लेस देन r. देखो हमने यहाँ पर लिखा था दिस z नॉट, दिस मॉड ऑफ z नॉट इज लेस देन r, और जब भी आपका मॉड ऑफ z नॉट लेस देन r हो जाता है तो ये सीरीज आपकी जीपी, ये तो सीरीज है ही जीपी, लेकिन साथ में कंडीशन होनी चाहिए कि मॉड ऑफ z नॉट शुड बी लेस देन r, वो हमने ऊपर बताया हुआ है. तो ये सीरीज़ आपकी क्या है, जीपी सीरीज़ हो गई, ठीक है. सो नेक्स्ट पेज. ओके, यहीं पर इसे फिनिश करते हैं. सो दिस सीरीज़ इज़ योर जीपी सीरीज़. मैं इसमें ऐड कर लेती हूँ एक पेज. सिंस summation n going from 1 to infinity mod of z naught over r the power n, this is a GP series with common ratio इसका common ratio वही है z naught over r which is less than 1 as z naught is less than r. ओके, देयरफॉर अब ये जीपी सीरीज़ है जिसमें कॉमन रेशियो ये है, और हमें पता है दिस इज़ कन्वर्जेंट, बिकॉज जीपी सीरीज़ अगर आपका जो रेशियो लेस देन 1 हो तो उसके लिए कन्वर्ज करती है, अगर ग्रेटर देन 1 हो उसके लिए डाइवर्ज करती है, ठीक है, इन केस ऑफ जीपी सीरीज़. सो आई विल राइट द रिमार्क फॉर जीपी सीरीज़. In GP series, if the ratio is less than 1, then it converges, and if the ratio is greater than 1, then it diverges. But if the ratio is equal to 1, then the series may converge or diverge. Okay, so this is a remark for you. So in my series it is less than 1, so it is convergent. So thus the summation n the power infinity z naught over r power n, this is convergent. अब ये कन्वर्ज हो गया, दैट मीन्स हमारा अगर ये कन्वर्ज है तो हमारा वो जो मॉड है वो एब्सोल्युटली कन्वर्ज हो गया, बिकॉज हमने मॉड कन्वर्ज शो किया. ये देखो यहाँ पर हम इसका मॉड स्टार्ट किया था हमने, इसका मॉड हमने अब आगे चल चल के इसको कन्वर्जेंट शो कर दिया है। तो अगर मॉड कन्वर्जेस दिस, इसका मतलब द सीरीज इज कन्वर्जेंट एब्सोल्युटली। देयरफॉर summation an z0 the power n is, सॉरी मॉड नहीं आएगा, this is absolutely convergent। जो सीरीज absolutely convergent होती है, this implies the series is convergent, but convergent series need not be absolutely convergent. An absolute convergent series always convergent. So this is convergent. This implies summation an z the power n, because z नॉट तो हमारा arbitrary है, ठीक है। So this is convergent at z equal to z नॉट, और z नॉट क्या है हमारा, arbitrary है, but z नॉट is arbitrary। इसका मतलब जितने भी आप z नॉट कंसिडर करेंगे सारी की सारी कॉम्प्लेक्स वैल्यूज़ के लिए भी ये कन्वर्जेंट है। Therefore the summation an set the power n, this converges for all values of complex numbers, hence the result। If your series is absolutely convergent, then now your series starts from 0 to infinity. Your series starts from 0 to infinity. And also this is, sorry, I'm very sorry, this is not 1, this is from 0 to infinity, this is from 0 to infinity। So thank you.